Hello, welcome to Genius Pro Online School. This is Tutor PVS. In this video, I have a question on simple machines, of course, in conjunction with other principles of physics, such as work. All right. A box of weight 50 newtons is being put up an inclined plane by a force of 75 newtons. I'm sure you can see by that arrow there. A friction force of 10 newtons is opposing the motion. You can see the motion here. Calculate the work done against gravity, velocity ratio, and mechanical advantage. So here we have the weight, the vertical height, and the angle of displacement. So how do we find the work done against gravity? All right, so the work done against gravity is just the force of gravity itself, then multiplied by the vertical distance. Remember that gravity is always acting downward, right? So remember, for work to be done, the force and the distance should be parallel to one another. So this distance here and the force, they are also parallel to one another. That is only when work can be done. All right. So I said work done by gravity is just equal to the force of gravity multiplied by what? The displacement itself. And in this case, it is the distance, the height here. Okay. The weight is 50 newtons. The vertical height is 5 meters. So we are getting our work done against gravity as 250 joules. That's all. Right? Now, B is finding velocity ratio. If you have been given an angle, all right? If you have been given an angle and you are asked to find velocity ratio, remember, sine theta is, it is the opposite over hypotenuse, right? In our case, it is just equal to the vertical height, because the side where the angle is facing is the opposite. So we have the vertical height, and the hypotenuse is this, the length from there to there, all right, which is the length of the inclined plane. Length of what? Inclined plane. So come here. This is where I'm going now, and I want you to pay particular attention. We know that height is actually 5 meters, right? So we are saying the angle here, it will be sine 30 degrees. The height is 5 meters, and the length we don't know, so just put L there. Okay, this will give us what? Length is 5 meters over sine 30. You can punch this on the calculator and you are getting length to be 10 meters. Now, how do we find velocity ratio? Velocity ratio is the effort distance you divide by load distance. What we just found here, okay, what we just found here is actually the effort distance. Okay, so it will be 10 meters divided by 5 meters, and this will be giving us what? 2. Or you can say velocity ratio is given by 1 over sine theta. This is also another formula. 1 over sine 30 degrees, 1 over 0.5 to give you 2. It's the same. I did this because I understand that you needed this knowledge. You needed to know that we can use trigonometry actually to help us find this length there. If you know that length there, then you can also find velocity ratio. They may not ask you to find velocity ratio. Sorry. They may ask you to find that length, given the angle and that. You apply this procedure, then you are fine. Or you can use this one to find velocity ratio. Do not add units because it's a ratio. Should you go to C? Okay. C is mechanical advantage. We know that mechanical advantage, MA, is the load. We divide by the effort. Let's go to the load. What is the load? You can pause. I want you to tell me the load. Is this the load? Now, before you even rush into saying, no, this is the load, careful. I know someone out there has told you to say, no, you are going to get this one direct. No. And here's the reason why. We've got our friend here. Let's not forget friction. It's been clear yesterday, friction. Okay? Now, here's the thing. We need to find the actual useful output force that the force, this force here is pulling or is overcoming. All right? Now, that component is actually just the component of the gravity itself, which is down, the gravity down, and the friction force. Think about this. Do you think this force, which is pulling this object, is just pulling the 50 Newton? Do you think? No. It's also pulling this friction force. So this plus this, they are going to give us what we call the resistive force. So what we need is, number one, we need the component of gravity downwards. So first find the component of gravity downward. Now the component of gravity downward will always be the weight itself multiplied by sine theta. So the weight is 50 newtons, then the angle is sine 30. So we end up having 25 newtons. Then the total resistive force now, total resistive force is equal to total resistive force, which is the output, is equal to 25 plus 10. This will give us 35 newtons. This becomes our load which we are going to use. So therefore, we say mechanical advantage to be 35 newtons over. The effort remains the same, 75 newtons, because it is the one that is pulling. Okay? So we put 75 newtons there to give us 0.467. Also, do not add unit. It's a ratio. What they asked you to find the efficiency. How do you find efficiency? So efficiency is equal to mechanical advantage divided by the velocity ratio multiplied by 100. So we get 0.467 over, what was the velocity ratio? 2 multiplied by 100. If we do 0.467 divided by 2 multiplied by 100, we end up having about 23.35%. But what does this number tell you about the simple machine? It's actually telling you that out of 100% energy input, only 23.35% has been put to good use. That means the rest has been wasted, maybe due to heat, sound, friction, and so forth. Are we together? All right. So I hope that you enjoyed the video, and you know the need. Subscribe.